Welcome to our second lesson. Make sure you have out that worksheet so you can follow along. What we're going to do is we are going to use those ratios to connect things across an equation. That's why these mole-to-mole calculations are central for all of stoichiometry. What we're going to do is we're going to start in the units of moles of one substance, which is going to be our given. All right, what we're given, what we're starting with, from some chemical equation. And we're going to end in units of moles of another substance, which is going to be our wanted. And this is all going to be across the same chemical equation. So it's moles to moles, two different substances, same reaction. These substances can be any combination of reactants and products. We can go from reactants to products, products to reactants, or we can go from reactants to reactants, products to products. What we're going to do is we're going to use this ratio of the moles of the wanted substance to the moles of the given substance that we got in our balanced chemical equation. And we're going to use this as a conversion factor. So we're going to connect them as a conversion factor. How do we use these ratios? So first step, identify the given quantity and the wanted quantity in a reaction. All right? What do we provided and what do we want to find out? Second, we're going to select mole ratios of coefficients, right, of the wanted and the given that are from the balanced chemical equation. And then we're going to multiply our given by that ratio to get what we want. All right, let's do an example. Here's our reaction. Pay attention that this is already a balanced reaction. Sometimes you will have to balance it first. Our question is, determine the number of moles of ammonia produced by reacting 12 moles of hydrogen. So first step, it also says we have sufficient nitrogen. This just means that we can ignore the nitrogen in this process. We have enough of it. We're not going to run out of that. So we can fully react the ammonia and the nitrogen together. First step, identify the given. The value we're given is 12 moles of hydrogen. The value we want to find out is moles of ammonia. Connect the wanted to the given in a mole ratio. So it's always wanted over given. And how we got these numbers was we used a balanced chemical equation. So this came from that. And that is where we got the 3 from. The coefficient 3 next to our hydrogen is our given on the bottom. The coefficient 2 connected with our ammonia is our wanted on the top. Next thing, we want to start our calculation with the given. Back in moles, we always started with one single number. So 12 moles of hydrogen is that given. Let's put it over 1 and set up a problem. So we're going to now take this ratio and use it to convert from units of hydrogen to ammonia. So let's put the 3 moles on the bottom of hydrogen because that will make sure that our moles of hydrogen will cancel. And then we'll put our 2 moles ammonia on top. When we do that, we can say that 12 times 2 is 24, divided by 3 is 8 moles of ammonia. And when you're done, make sure to check that the substance and units of your answer match with what was wanted, which it does, moles of ammonia. So it's one step. Okay, let's try it. So here's our reaction. Here's our problem. Determine the number of moles of oxygen required to completely react with 6.35 moles of phosphorus. Take a minute. First, find out what it is, identify the given and the wanted. All right, pause the video and come back in a second. All right, so hopefully you guys have identified the given and the wanted. The given are 6.35 moles of phosphorus. Wanted is moles of oxygen. Okay, Now, pause the video again in a second to connect the wanted and given to the coefficients from the chemical equation. All right, pause the video, connect them in a ratio, and we'll check to see if you did it all right. All right, here is our ratio. Wanted over given. Wanted is for oxygen, 5 moles. Given, 4 moles. Now, pause the video again, starting off with the given to solve the problem. When you play, I'll go through the rest. All right, let's do the rest. Oh, sorry. We are going to start with 6.35 moles of phosphorus over 1. Always start with the one thing by itself. Set up our fraction. We're going to now take this and plug it in, making sure that our units will cancel. Moles of phosphorus on the bottom, 5 moles oxygen on the top. Moles of phosphorus cancel out, and you're left with oxygen. Let me plug this into my calculator. I got 7.94 moles of oxygen. When you're done, check your units to make sure that your wanted match your answer. And they do. Great. Let's do one more example. Here it is. Here's a problem. How many moles of CS2 are produced when you're given 3.49 moles of S8? All right, pause it and try to do the whole thing on your own. All right, now I'm assuming that you guys have given a shot. Let's just go straight through. So, wanted is moles of CS2. Given, moles of S8. All right. So we are going to start with our 3.49 moles of S8. We need to put together that ratio. So it's always wanted over given, right? So my wanted is moles CS2, and I've got 2 of them. 2 moles CS2 over, don't forget that 1, imaginary 1 there, 1 mole S8. And make sure to plug that in now. 1 mole S8, make sure that those units cancel, to 2 moles CS2. Plug it into a calculator. 6.98 moles CS2. Check to see that those units match what we wanted, and they do. Let's do one more problem. Oh, it's a little covered. Sorry, but it says how many moles of H2S are also produced. So what we're going to do is we're still going to start with 3.49 moles S8. All right, same given. So wanted this time, moles H2S. Given, 3.49 moles S8. Wanted over given, our ratio, oops, that's a G, will be wanted is 4 moles right here, H2S. Given is CS2, again, 2 moles. Oh, this is the wrong one. Let's see, this is going to be 1, sorry. 1 mole of S8. All right, let's set this problem up. So we're going to start with our given, 3.49 moles S8. bring this over. 1 mole S8. Making sure that those units can cancel because they're the same. 4 moles H2S. And let's do that math. There's our answer. Make sure that our units and substance match what we are trying to find out. Ooh, right here. So we just use those coefficients as a ratio and use it as a one-step conversion between moles of one thing to moles of another. I'll see you in class.